Hello and welcome to the episode 7 of PyTorch Code Deep Dive. This episode starts a series of episodes about Torch Neural Network Module. In this episode, I will show how such module is constructed. If you find presented content useful, don't forget to press the like button and subscribe. I'm using an example from the official PyTorch documentation, a simple neural network module with flatten and linear rail stack modules. This example initializes neural network object and prints its content. The output contains detailed information about the module and all of its submodules. Let's deep dive to see what happens. In the beginning, there are some checks for the versions of the modules that call parent module init. The next set of statements set attributes of the module. Instead of setting them directly, Python magic method is used. This is because setattr method is overridden by this module class. Module class contains set of collections representing content of the module and hooks. If call to superinit is allowed, it happens as a last step. Let's see what happens when first submodule is set. I will skip flatten module initialization logic as it's not relevant at the moment. Once assigning this new attribute, the custom setAttribute method is called. The overall logic of this method is to check what type of argument is passed in. Firstly, it checks whether it's a parameter. Then it checks if it's a module, and so is the case here. There's additional check if modules were correctly set. Object cannot have two attributes of the same name, as that would cause a collision. So there's a trial of removing the attribute of the same name from the buffers and parameters, or directly from the object, in case it already exists there. Since this is a first attribute assignment, we don't expect any collision to happen. Anytime new attribute is set, module can notify registered hooks about this. By default, such list is empty. The underscore modules attribute contains the dictionary that will store all submodule objects, flatten in this case. Similarly, for the next linear rail stack module, the logic is repeated in the same way. If the module of the same name is passed, it will be overridden in the module's dictionary structure. Let's see what happens if other type of attributes are assigned. I will create parameter and buffer objects and simple attribute of integer value. I will skip parameter initialization. Since the type of assigned value is parameter, there's a check if parameter exists in buffers and modules dictionary. Then, register parameter is called, which is a public method that can be called directly on module object. As a result, we will have a parameter attribute created in the module. This method performs various initial checks. If underscore parameter structure is available, if name is non-empty string that does not contain dot. There's additional check to make sure we set parameter type instance. Finally, all register hooks are notified and parameter is assigned to the underscore parameters dictionary. There's a similar situation with the buffer. As buffer is not a parameter nor module, it's checked against buffer structure. Some modules don't implement register buffer correctly, therefore, this checked. The public register buffer function is called, which performs similar checks as register parameters. Additionally, it's checked if buffer is a subtype of tensor. In case buffer is not persistent, it is additionally added to separate set or removed otherwise. What if any other type of value is set? If the value is neither a module, nor parameter, nor buffer, it's simply set as a regular class attribute. In this video, I showed how Neural Network Module is initialized. In the next video, I will show what happens on accessing and changing the attribute values and how hooks can be used. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.